Select all the true statements. So if we are working with theta, here's our, drives me nuts that it does that. Here's our hypotenuse, here's our opposite, here's our adjacent. Oh, excuse me. So if we're looking at this one here, cosine of theta is equal to 5 over 12. Remember that cosine is adjacent over hypotenuse, which would be 12 over x. So this one we can eliminate. We also know that if we are trying to find theta, then we can use those inverse. This is the same thing as tangent inverse, that tan -1. And so if we do the arctan, or inverse of tangent, 5 over 12, that's opposite over adjacent, this one would be correct. Because remember, tangent is opposite over adjacent. Theta is the angle that we're working with, and so the opposite is 5, and the adjacent is 12. And so this would be the inverse tangent of 5 over 12, which is the same thing. Tangent inverse and arctan, those are the same thing. Okay, so now we're going to talk about side length AC. So if we want to find out what the length of AC is, we can use the Pythagorean theorem. So a squared plus b squared is equal to c squared. So this is c, and then these two are both a and b. And remember, a and b don't matter where they go as long as they are the legs. C has to be the hypotenuse. So we have 5 squared plus 12 squared is equal to x squared. So 25 plus 144 is equal to x squared. 25 plus 144 is 169. And the last step of the Pythagorean theorem is always to take the square root, and we get x is equal to 13. So this is not correct because that would be 13 would be a square root of 169. So this one is not correct, but this one is. And then lastly, we want to look at alpha. Here's our hypotenuse, here's our opposite, here is our adjacent. And so if we're talking about the sine of A, sine is opposite over hypotenuse. We just found that this side length over here is 13. And so if we do the sine, we get the opposite over the hypotenuse, which is 12 over 13.